What if I told you there's a creature alive today that was already swimming in the deep when the Titanic sank, or even when Leonardo da Vinci was painting the Mona Lisa? A mysterious giant that lurks in the coldest corners of the ocean, living, longer than any other vertebrate on Earth, and yet barely anyone has ever seen it. What is this animal? How does it survive for centuries in complete darkness? And what secrets could it hold about time, aging, and the hidden world beneath the ocean? Deep beneath the icy waters of the North Atlantic and Arctic Oceans lives a creature so mysterious and ancient that it seems almost mythical. The Greenland shark, scientifically known as Sonmiosis microcephalus, is one of the largest and longest living vertebrates on Earth. These slow-moving giants are found primarily around Greenland, Iceland, and parts of Canada and Norway. Despite their size and longevity, they remain elusive, often hidden in the cold darkness of deep waters, far from human reach. Greenland sharks can grow to enormous lengths, with some individuals reaching up to 24 feet long, though more commonly. They are about 10 to 15 feet, weighing over 1,000 pounds. Their massive size is matched by their remarkably slow movement. They have a torpedo-shaped body and a short, rounded snout, with small eyes that often carry parasitic copepods clinging to the surface. These copepods may cause partial blindness, but the sharks don't rely heavily on vision. Instead, they use an acute sense of smell to navigate their murky world and locate prey. Their skin is rough, sandpaper-like, and covered in dermal denticles, which reduce drag and allow smoother movement through the water. Their coloration is typically a mottled gray to brown, helping them blend into the deep-sea environment. Unlike most fast-moving sharks, Greenland sharks are built for endurance rather than speed. They glide silently and slowly through the frigid waters, a method of conserving energy in a habitat where food can be scarce. What sets the Greenland shark apart from nearly all other species is its astounding lifespan. Scientists have estimated that these sharks can live for centuries. The oldest Greenland shark ever studied was estimated to be around 392 years old, with a possible age range of 272 to 512 years. This extraordinary age estimate was determined through radiocarbon dating of the eye lens nucleus, a technique that has revolutionized the understanding of deep-sea longevity. It means some sharks alive today may have been swimming through the ocean when the Mayflower sailed, or even earlier. These animals grow incredibly slowly, at an estimated rate of about 1 centimeter per year. They don't reach sexual maturity until they are about 150 years old. That means a shark born in the mid-1800s might only recently have begun to reproduce. This slow growth and late maturity pose serious challenges for population recovery if numbers decline, making them particularly vulnerable to overfishing, and BYCATCH. Greenland sharks are opportunistic feeders. Their diet includes fish, squid, and carrion, such as seals or whales. Incredibly, remains of polar bears, moose, and even reindeer have been found in their stomachs, suggesting they scavenge dead animals that fall into the sea. While they are not known as active predators of large animals, they are believed to ambush or feed on incapacitated prey and take advantage of whatever nutrition is available in the frigid deep. The sharks inhabit depths of up to 2,200 meters, but can also be found at shallower depths, particularly in Arctic fjords. They are known to migrate vertically and seasonally, possibly in response to water temperature or prey availability. They prefer temperatures close to freezing, and their bodies are uniquely adapted to such extreme cold. They have high concentrations of trimethylamine N-oxide, a compound that protects proteins against the damaging effects of urea in cold temperatures. However, this compound also gives their flesh a high toxicity if consumed fresh, causing symptoms of intoxication in humans and dogs. Greenland shark meat must be fermented or boiled repeatedly, and dried before it's considered safe to eat, a practice still maintained in Iceland, where the dish is known as hakaro. Despite their fearsome appearance and size, there are no confirmed cases of Greenland sharks attacking humans. They are reclusive, living in environments where human contact is rare. Their sluggish movement and scavenging behavior also reduce any potential threat to people. Still, their mysterious presence in the dark Arctic depths has inspired folklore among indigenous communities in Greenland and Canada. Inuit legends speak of the shark as a supernatural being or a feared predator of the deep, earning names that translate to things like sleeper shark or big sleeper due to their slow, dream-like movement. In scientific research, Greenland sharks represent an invaluable subject. Studying them can provide clues about aging, disease resistance, and life in extreme environments. Their physiology is remarkably resistant to the degenerative processes associated with aging in other animals. Understanding how their tissues, organs, and DNA withstand the passage of centuries could one day help researchers unlock new strategies for extending human health span and treating age-related conditions. There is still so much unknown about their behavior, mating, and population size. They are believed to be solitary for much of their lives, but little is confirmed about their reproductive habits. Pups are thought to be born live, as Greenland sharks are ovoviviparous, with litters ranging from 10 to 100. However, no one has ever witnessed a Greenland shark giving birth. Much of what scientists believe is based on the dissection of specimens and comparison with related species. Because of their slow reproduction and unknown population dynamics, conservation efforts are critically important. While they are not currently listed as endangered, the Greenland shark is considered near threatened by the IUCN. Bycatch in commercial fishing operations poses the greatest risk. These sharks are often unintentionally caught in trawls and long lines, and because of their depth and range, they are especially difficult to monitor. Climate change also presents an emerging threat, as warming ocean temperatures and melting Arctic ice could alter their habitat and food availability. Efforts to protect them include fishing regulations in some parts of the Arctic and tagging studies to understand migration and behavior. Satellite tags have been deployed on a number of individuals, revealing that some sharks migrate thousands of kilometers over months or years. These long-distance movements challenge the earlier belief that Greenland sharks are mostly sedentary, and highlight the need for international cooperation in managing their conservation. Greenland sharks belong to the sleeper shark family, Somniacidae, and are closely related to other deep-sea sharks like the Pacific sleeper shark. They share many traits such as slow movement, deep water habitats, and scavenging diets. The evolutionary adaptations of this group provide insight into how life can thrive in the most hostile environments on Earth. By studying these deep-sea creatures, scientists can learn more about evolutionary pressures, energy conservation strategies, and ecological roles in cold, dark ecosystems. The discovery of such a long-lived species also raises philosophical questions about time, endurance, and the nature of life itself. A single Greenland shark may have lived through centuries of human history without ever surfacing into our world. Its perspective, though unknowable, suggests a life rhythm vastly different from our own. For an animal to glide silently beneath the ice for hundreds of years, enduring countless seasons and changes in ocean chemistry and temperature, is a humbling reminder of the complexity and endurance of nature. Although they move slowly, Greenland sharks are not inert. They interact with their ecosystem in ways we are only beginning to understand. Their scavenging helps recycle nutrients in deep-sea environments. They may help regulate populations of other species through opportunistic predation. And their very presence shapes the behavior of prey species and smaller scavengers. Even parasites like the eye-dwelling copepod depend on them to complete their life cycle. These sharks are part of a delicate, ancient web of life that has persisted for millennia. As technology improves and interest in the deep sea grows, more discoveries about Greenland sharks are likely on the horizon. Remotely operated vehicles and deep-sea submersibles offer glimpses into their world, capturing footage and behavior never before seen. Genetic studies and tissue sampling provide further insights into their biology and resilience. But for now, the Greenland shark remains one of the ocean's most intriguing mysteries. It is a creature shaped by time and pressure, by darkness and cold, by evolution and endurance. It reminds us that the world still holds secrets, and that some of nature's most extraordinary marvels lie hidden in the quiet places we seldom dare to go. The mystery surrounding the Greenland shark continues to deepen with every new piece of information scientists uncover. Even with technological advancements, these creatures are notoriously difficult to study due to the depths at which they live and the remote nature of their habitats. Most of what is known has been gleaned from accidental catches, dead specimens washed ashore, or from sharks that have been tagged with data loggers. Yet these glimpses offer only fragments of a much larger picture, one that continues to elude marine biologists and oceanographers alike. One area of increasing interest is how Greenland sharks navigate such extreme environments. Without relying much on vision, they appear to use a combination of olfactory cues, electroreception, and possibly geomagnetic fields to orient themselves in the vast darkness. This would place them among the many marine animals believed to use Earth's magnetic field as a kind of built-in GPS. Their ability to traverse thousands of kilometers through an environment nearly devoid of light suggests an advanced and highly adapted internal navigation system that humans have barely begun to understand. The shark's metabolism is another area of fascination. Greenland sharks have one of the lowest metabolic rates recorded among sharks, which is likely an adaptation to the cold, food-scarce conditions of the deep Arctic waters. This slow metabolism aligns with their slow growth rate and exceptional longevity. It means they require less food, conserve energy more efficiently, and likely have a reduced rate of cellular damage over time. Some researchers believe this may be one of the biological keys to their impressive lifespan. Studying these metabolic mechanisms could help scientists understand how metabolic rate correlates with aging, potentially leading to breakthroughs in gerontology and human health. While most sharks are known for their relatively active hunting styles and speed, Greenland sharks are more akin to quiet giants. Their sluggish behavior has led to a common misconception that they are clumsy or ineffective predators. However, their adaptations tell a different story. Their slow speed is matched by an ability to capitalize on stealth and environmental camouflage. In the pitch-black waters where they dwell, the concept of speed is less relevant than patience and persistence. If they do hunt, it's likely through ambush tactics or by targeting prey that is sick, injured, or otherwise impaired. Some researchers hypothesize that Greenland sharks may also feed by creating suction to draw in prey rather than relying on speed. Their large mouths and powerful jaws could support this theory. Interestingly, their teeth are differently shaped on the upper and lower jaws. The upper teeth are pointed and act to grip prey, while the lower teeth are broad and serrated, allowing the shark to cut through flesh with a sawing motion. This dentition suggests a capacity to feed on large carcasses or to remove large pieces of tissue from prey. It's a method well suited to scavenging, but also capable of predation under the right circumstances. Despite their incredible lifespan and resilience, the Greenland shark's reproductive strategy remains largely speculative, most of it limited. Data on reproduction comes from dissections of females caught as bycatch. Observations suggest that gestation may last several years, and females may give birth to live young, measuring around 35 to 45 centimeters in length. Given their slow growth, those pups would take decades to reach even half their adult size. The lengthy gestation and late sexual maturity mean that any population loss could take centuries to recover, making them especially susceptible to even minor increases in mortality. One of the more bizarre and unsettling aspects of Greenland sharks is their toxic flesh. The meat contains high levels of urea and trimethylamine oxide, which serve as antifreeze-like compounds in the shark's blood. While beneficial to the shark's survival in icy water, these chemicals are harmful to humans and can cause symptoms ranging from nausea and vomiting to a drunken-like stupor. In traditional Icelandic cuisine, the meat is buried and fermented for several months to render it safe to eat. Though considered a delicacy by some, it's often described as having a strong ammonia smell and is generally an acquired taste. Parasites also play a curious role in the life of the Greenland shark. One of the most well-known is Amatocoida elongata, a species of copepod that attaches itself to the shark's cornea, often leaving the host partially or fully blind. The parasite's presence raises intriguing questions. Some scientists have speculated that the bioluminescent copepod might actually help attract prey closer to the shark's mouth, although this theory remains unproven. Regardless, the relationship between the parasite and the shark highlights how little is understood about deep-sea ecological interactions. Greenland sharks also play a potentially crucial role in their ecosystem, functioning as apex or mesopredators, depending on the specific region. By feeding on dead or dying marine animals, they help recycle nutrients and maintain the health of oceanic food chains. In areas where large whale populations once thrived, Greenland sharks may have played an essential role in processing whale carcasses, preventing the buildup of decaying organic matter on the ocean floor. As such, they occupy a unique ecological niche and contribute to the overall balance of Arctic marine systems. The more scientists study them, the more they realize that Greenland sharks could be sentinels of climate change. Because they inhabit such specific and extreme environments, any significant shift in water temperature, salinity, or ice cover could have profound effects on their survival. Melting Arctic ice and warming waters are likely to push Greenland sharks into deeper or more remote regions, further complicating research and potentially limiting their access to prey. As top predators with long lifespans, their population trends can offer a long-term indicator of the health of Arctic marine ecosystems. International efforts are slowly beginning to recognize the importance of protecting these ancient sharks. Canada and Norway have conducted population assessments, and in some regions, catch limits or full bans on harvesting Greenland sharks have been put in place. The Convention on International Trade in Endangered Species of Wild Fauna and Flora has not yet listed the Greenland shark, but growing concern among scientists may prompt future regulatory changes. Public awareness and educational outreach are also vital to ensuring the long-term survival of these remarkable creatures. The cultural significance of Greenland sharks cannot be overlooked either. For generations, indigenous peoples of the Arctic have included them in their stories, diets, and survival strategies. While their meat was once used for dog food or fermented for human consumption, their presence in folklore is often symbolic of endurance, patience, and the quiet strength needed to survive in harsh conditions. In some Inuit traditions, the shark is viewed with reverence and caution, considered a creature of the deep that must be respected but not feared. With each passing year, new studies continue to chip away at the mystery of the Greenland shark. Tissue sampling, isotope analysis, and genetics are revealing information about their diets, migrations, and even their evolutionary history. There is growing interest in how they withstand such long lifespans without succumbing to common age-related diseases. Do they possess unique genes for DNA repair, or cellular regeneration? Are their immune systems more efficient at fending off disease and cancer? These are questions researchers are actively investigating. Beyond the science, the Greenland shark captivates the human imagination because it embodies something rare in the modern world, a sense of the truly unknown. In an age where most terrestrial creatures have been thoroughly studied and catalogued, the Greenland shark reminds us that some corners of our planet still guard their secrets fiercely. There's something profound about knowing that beneath the Arctic ice, in a world of silence and darkness, lives a being that may have swum past wooden ships centuries ago and continues its journey today with no concern for human history. Creature is not just a biological marvel. It is a living time capsule, drifting slowly through the depths with the weight of centuries behind it. Every scar on its skin, every parasite on its eye, every strange meal in its belly tells a story we are only beginning to decipher. Its ancient heart beats slowly, methodically, as it has for hundreds of years, indifferent to the fleeting lives of those who seek to study it. And perhaps that is the most powerful lesson it offers us, the value of patience, of endurance, and of life lived far from the noise of the surface world. Efforts to study and understand the Greenland shark are pushing the boundaries of marine science, requiring not just traditional biological methods, but also cutting-edge technology and interdisciplinary research. For instance, researchers are using satellite telemetry and acoustic tagging to track the movements of individual sharks. These tools allow scientists to collect long-term data on depth, temperature preference, and geographic range. Some tagged individuals have revealed surprising migratory behavior, moving from the Arctic deep to areas as far south as the North Atlantic's temperate zones, sometimes covering thousands of kilometers. This contradicts earlier assumptions that they are strictly local or sedentary, suggesting that these sharks may be much more wide-ranging than previously believed. Even with these advanced tools, challenges remain. The slow-moving nature of Greenland sharks makes them difficult to locate and tag. Their natural habitat, often deeper than 1,000 meters, lies beyond the reach of most standard diving operations. Research vessels equipped with submersibles or remotely operated vehicles are expensive to operate and require specialized crews. Despite these obstacles, every successful encounter with a Greenland shark adds valuable data to the scientific record, inching closer to a fuller understanding of this enigmatic species. Another promising area of research lies in the genetic makeup of Greenland sharks. Their DNA is being analyzed for clues about their long lifespans and ability to avoid many of the age-related illnesses that afflict other vertebrates. Preliminary findings suggest that their cellular repair mechanisms may be highly efficient, and their low metabolic rate might reduce oxidative stress on their cells. Scientists are particularly interested in telomeres, the protective caps at the ends of chromosomes that typically shorten with age in other animals. If Greenland sharks maintain their telomeres for longer or regenerate them more effectively, it could offer insight into biological aging processes across species. The Greenland shark's immune system is also of interest. Living for centuries in deep, cold waters filled with bacteria and decaying organic matter likely demands a strong and resilient immune defense. Understanding how these sharks fend off infections over such long lifespans could have applications in human medicine, especially in areas related to immunity, chronic disease, and even cancer research. There is growing speculation that these sharks could possess natural biochemical defenses that help suppress tumor growth or prevent systemic infections, though this remains a field of exploration. Despite the vast unknowns, what is already known about Greenland sharks challenges many of our assumptions about sharks in general. Popular culture often portrays sharks as fast, aggressive, and dangerous apex predators. Greenland sharks, in contrast, are slow, quiet, and elusive, yet no less formidable in their own ecological role. their longevity, and deep water habitat. Place them outside the typical narrative, showing that success in nature isn't always about speed or ferocity. It can also be about endurance, adaptability, and subtle dominance over time. There are also indications that Greenland sharks may interact with other deep-sea species in ways we haven't yet observed. Their scavenging habits suggest they might play a part in shaping the community structure of deep-sea ecosystems by redistributing nutrients and influencing the population dynamics of other organisms. Their occasional presence near whale falls locations where deceased whales settle on the seafloor has led to speculation that they may play a role in the decomposition process and in nutrient cycling over extended timescales. Interestingly, some researchers have raised questions about the potential for deep-sea noise pollution to affect these slow-moving giants. As human activity increases in previously undisturbed Arctic regions, the rise in underwater noise from ships, ice-breaking vessels, and offshore drilling may disrupt the natural behavior of Greenland sharks. Because they likely rely on low-frequency environmental cues for navigation and hunting, increased acoustic interference could disorient them or alter their migration patterns. Long-term studies are needed to understand these potential impacts and to advocate for quiet zones in critical habitats. The cultural and symbolic importance of Greenland sharks is beginning to spread beyond the Arctic as more people around the world learn about this ancient species. Documentaries, research publications, and online platforms have helped bring attention to the shark's unique qualities, turning it into an icon of deep-sea conservation. Scientists and environmentalists often use the Greenland shark as an example of why protecting the oceans means looking beyond the surface and recognizing the value of creatures that thrive in places we seldom see. For those fortunate enough to study these sharks up close, the experience is often described as surreal. Divers and researchers recount moments of coming face-to-face with a creature so large, so calm, and so ancient that it feels like encountering something out of prehistory. With their slowly drifting forms, clouded eyes, and mouths seemingly frozen in a subtle grin, Greenland sharks evoke both wonder and reverence. They are reminders of a natural world that exists on timescales vastly different from our own. In the greater context of marine life, the Greenland shark represents the extreme end of a spectrum. It is not only one of the longest living vertebrates, but also among the slowest growing, latest maturing, and most metabolically conservative. Its physiology, behavior, and habitat all stand as exceptions to the usual rules, challenging biologists to rethink what life in the ocean can look like. In doing so, it helps broaden the understanding of biodiversity and evolution in Earth's most extreme environments. It's worth noting that Greenland sharks have been caught as bycatch in commercial fisheries for centuries, often discarded due to their toxic meat. In the past, their liver oil was valued for use in lamp oil and industrial lubricants. Modern conservation efforts aim to reduce such accidental catches through improved fishing practices and protected zones. As understanding of their ecological importance grows, so too does the recognition that every individual shark lost could represent the end of a journey that began hundreds of years ago. Conservationists stress the importance of adopting a long-term view when it comes to managing Greenland shark populations. Because of their slow reproductive rate, a single generation can span multiple human lifetimes. Efforts to protect them must therefore be forward-thinking and intergenerational, involving not just immediate action, but sustained international cooperation across decades or even centuries. Protecting their cold water habitats, regulating deep-sea fisheries, and promoting public awareness are all steps in the right direction. One of the most haunting and beautiful ideas that surrounds the Greenland shark is the realization that some of them alive today were born long before the invention of electricity, the publication of Darwin's Origin of Species, or the founding of modern science itself. These animals may have swum beneath explorers, submarines, and fishing vessels without ever being noticed. They are witnesses to history, not just in the human sense, but in the ecological and planetary sense. Their lives, unfolding slowly beneath ice sheets and Arctic currents in an existence so different from ours that it borders on the poetic. To truly appreciate the Greenland shark is to accept that we don't need to conquer or control nature to find meaning in it. Sometimes, the most profound encounters come not from imposing ourselves on the natural world, but from recognizing the majesty of what already exists. In its long life, slow swim, and silent watchfulness, the Greenland shark offers something rare, a connection to deep time and to a world that predates us, outlasts us, and reminds us that the ocean still holds mysteries no technology can yet unravel. The future of Greenland shark research will likely depend on continued collaboration between scientists, conservationists, governments, and indigenous communities. Each group brings a unique perspective that enriches the understanding and protection of these elusive giants. Indigenous knowledge, for example, offers insights into historical sightings, local migration patterns, and ecological relationships that have been passed down for generations. In regions like Greenland and northern Canada, where the sharks have long been part of the natural landscape, this traditional knowledge is increasingly being integrated with modern scientific approaches. Academic institutions and marine research organizations are also developing new methods to study Greenland sharks without causing them harm. Non-invasive technologies like environmental DNA sampling are becoming more common. This technique involves collecting water samples and analyzing them for traces of genetic material left behind by the sharks. It offers a way to detect their presence in remote locations without the need for direct capture or observation. As these methods improve, researchers hope to map out a more comprehensive picture of the shark's distribution, behavior, and population trends across different seasons and regions. Climate change continues to be a major variable in the fate of the Greenland shark. As ocean temperatures rise and sea ice retreats, changes in prey distribution, water chemistry, and competition from other marine species could impact their survival. Warmer waters might force Greenland sharks to migrate to deeper, colder areas, potentially limiting their access to traditional feeding grounds. Simultaneously, new shipping routes opening in the Arctic could increase the risk of pollution and noise, disturbances in previously untouched environments. These changes highlight the interconnectedness of ecological systems and the vulnerability of even the most ancient creatures to modern environmental pressures. Marine protected areas, or MPAs, may offer some refuge for Greenland sharks. By designating key regions of the Arctic and North Atlantic as conservation zones with restricted human activity, governments and organizations can create safe havens for slow-growing species like the Greenland shark. However, enforcing these protections in such vast and remote territories presents a significant logistical challenge. That's why international cooperation is essential. Arctic nations must work together to monitor shark populations, establish consistent policies, and fund long-term research programs that span borders and generations. Public interest plays a critical role in these efforts. As awareness of the Greenland shark's uniqueness spreads, it becomes easier to advocate for its protection. Documentaries, scientific outreach, and viral content about the shark's incredible lifespan have helped spark curiosity and concern among people who might otherwise never hear of this deep-sea species. Educational campaigns can inspire new generations of marine biologists and conservationists, ensuring that research and protection efforts continue into the future. This cultural momentum is crucial for building political will and allocating resources toward conservation strategies. One of the most fascinating aspects of Greenland shark research is the idea that the true extent of their lifespan might still be underestimated. The current age estimates are based on the oldest individuals studied so far, but there is no reason to believe these sharks can't live even longer under the right conditions. If one were to survive into its upper lifespan, range perhaps over 500 years, it could feasibly witness both the dawn and demise of entire human civilizations. This longevity turns each Greenland shark into a kind of living fossil, an organism that bridges centuries of ecological and climatic change, offering a perspective beyond anything humans can personally experience. In fact, some scientists consider Greenland sharks as ideal models for studying resilience in the face of planetary stress. Their capacity to endure cold, low light, limited food availability, and chemical buildup in their tissues is almost unparalleled. Understanding how they regulate internal systems and maintain cellular function under such conditions could have implications for biomedical research, particularly in areas like cryobiology and organ preservation. Their longevity and stability could unlock strategies for slowing aging or increasing tolerance to harsh environments in other species, including humans. It is also worth considering the Greenland shark's place in the evolutionary tree. As members of the sleeper shark family, they represent a lineage that has remained relatively unchanged for millions of years. This evolutionary stability suggests that their design is incredibly well suited for the ecological niche they occupy. Their ancient genetic code may hold answers to how vertebrate life adapted to cold, dark environments long before human civilization arose. Fossil records and comparative genomics could help trace the evolutionary path that led to such a resilient species, shedding light on the broader history of life in Earth's oceans. As we deepen our understanding, ethical questions also arise. Should humans continue to interact with a species that may live longer than our institutions, governments, or even civilizations? What responsibility do we bear for ensuring that our presence in the oceans does not disrupt the natural rhythms of creatures that have survived without us for so long? These are not just scientific questions, but philosophical ones. The Greenland shark confronts us with the idea that our world is shared with beings whose experiences, timelines, and senses of existence are radically different from our own. In literature, art, and storytelling, the image of the ancient shark gliding through the deep has begun to take root. It symbolizes something eternal and mysterious, an emblem of the unknown that still exists on a planet increasingly shaped by human hands. Artists, writers, and filmmakers are using the Greenland shark as a muse to explore themes of time, endurance, and nature's quiet persistence. These cultural interpretations, while not scientific in themselves, help embed the shark into the public imagination in a way that statistics and data alone cannot achieve. Ultimately, the story of the Greenland shark is one of resilience. It has survived ice ages, shifts in sea level, the Industrial Revolution, and the rise of global shipping routes. It has witnessed the birth of modern nations, the extinction of countless species, and the warming of the oceans. And still, it moves slowly, steadily, and silently through waters colder and deeper than most life can tolerate. It is not a creature that dominates through speed or aggression, but one that endures through patience, adaptation, and sheer longevity. To encounter a Greenland shark, even indirectly, is to brush against the ancient fabric of life itself. Its world is not our world, yet it is part of the same earth. Its heartbeat, slow and unwavering, has outlasted wars, empires, and entire generations. And though we may never fully grasp its secrets, we are richer for having glimpsed its shadow. In the deep, it reminds us that not all stories are fast or loud. Some unfold over centuries, in silence, beneath the ice. And those are often the ones most worth listening to. The Greenland shark's quiet existence in the deep ocean is not just a curiosity of marine biology, it's a living testament to nature's ability to craft creatures that, operate on scales of time and space completely foreign to human experience. It is no exaggeration to say that these sharks are among the least understood large animals on Earth. Nearly everything about their lives, from how they reproduce to what they do daily in the deep sea, remains cloaked in mystery. This isn't for lack of trying. It's simply that the environment they inhabit is one of the least accessible on the planet, and their behavior is adapted to evade attention. Unlike animals that flash, leap, or roar, the Greenland shark slips by unnoticed, always just beneath the radar of human senses and instruments. Many marine biologists consider the Greenland shark a black box, species a creature about which so little is concretely known that even the most basic assumptions must be made cautiously. For example, while the general reproductive mechanism of oviviparity, bearing live young that develop from eggs inside the mother, is suspected based on anatomical observation, no human has ever directly observed Greenland shark mating behavior or birth in the wild. No nursery grounds have been discovered. No footage exists of their courtship, gestation, or parental behaviors, if any. We simply don't know. This gap in understanding makes each new discovery particularly valuable. When a Greenland shark is accidentally caught or studied, scientists examine it thoroughly for any clues: parasite load, stomach contents, reproductive organ status, chemical composition of the tissues, isotopic signatures indicating diet and depth. In many cases, these single observations must stand in for decades of unknown life history. For a species that may live over 400 years, even tagging a few individuals provides only a snapshot in an incredibly long timeline. Yet even these snapshots have yielded surprising insights. One such insight came when researchers discovered that Greenland sharks likely have very slow embryonic development and incredibly long gestation periods, possibly even extending beyond a decade. If true, this would make them contenders for the longest known pregnancy in the animal kingdom. It aligns with their broader pattern of extreme biological pacing, slow growth, delayed maturity, infrequent reproduction, and great longevity. Everything about the Greenland shark seems to operate in slow motion, a kind of evolutionary patience that has clearly served it well in the frigid, food-scarce abyss. Another field of inquiry centers on the shark's brain and central nervous system. With such a slow metabolism in cold habitat, researchers are keen to understand how their brains function. Do they process information more slowly? Do they sleep or enter states of reduced awareness? Some evidence suggests that these sharks are capable of complex navigation and possibly even social behavior, but no long-term studies of their cognitive capacities have yet been conducted. What's more, their relatively simple brain structure raises questions about the role of intelligence and consciousness in survival strategies that don't rely on social interaction or rapid decision-making. Dietary studies have painted a more complete picture of what sustains these massive animals over such long lives. Through isotope analysis and stomach content examination, researchers have confirmed that Greenland sharks are both predators and scavengers. They eat a wide range of marine life, including fish, squid, seabirds, seals, and carrion from larger animals like whales. Occasionally, unexpected prey like moose or polar bears turns up in their digestive tracts, likely having fallen into the ocean after dying near the coast. These findings point to an opportunistic strategy where the shark does not discriminate. Whatever is slow, dead, or unfortunate enough to be within reach may become a meal dot despite their relatively low activity level. Greenland sharks are surprisingly successful in their ecological niche. Their stealth, combined with a powerful bite and the ability to withstand long fasting periods, makes them efficient when the opportunity arises. Their role as deep-sea cleanup crews, consuming dead and dying animals, helps maintain ecosystem balance by recycling nutrients that would otherwise accumulate on the ocean floor. They are part of the deep-sea community's hidden but essential processes, contributing to the health of marine systems in ways that are still being uncovered. One of the most poignant realities of the Greenland shark's life cycle is how invisible it remains despite its size. A creature that can grow to over 20 feet long and weigh more than a ton could reasonably be expected to leave a visible mark on the ecosystem. Yet because it lives far below the surface and interacts only minimally with humans, it often goes unnoticed in discussions of ocean conservation. This invisibility is both a strength and a weakness. On the one hand, it protects the shark from exploitation to some extent. On the other, it makes it harder to advocate for protections or raise awareness of its ecological importance. A further complication arises when considering how little we know about their population numbers. Are Greenland sharks abundant, rare, or somewhere in between? The lack of long-term data and the difficulty of observing them make it hard to determine trends. Some models suggest that they could be declining due to bycatch and habitat disturbance, while others hold out hope that they are more numerous than we think, simply staying out of sight. The truth likely lies somewhere in the middle. Given their extremely slow life history, even a modest uptick in mortality rates, whether from fishing, habitat loss, or pollution, could have dramatic consequences over time. Understanding and managing such a species presents a challenge to conventional wildlife conservation models. Greenland sharks do not reproduce quickly, migrate predictably, or gather in large groups that are easy to track. Their populations cannot be easily surveyed with aerial counts or surface tagging. Instead, scientists must rely on scattered data points, modeling, and inference. This makes it all the more important to develop creative and collaborative approaches to studying and protecting them, drawing on satellite data, indigenous observations, international fishing records, and more. Even more speculative are discussions about what role the Greenland shark might play in future ecosystems shaped by climate change. As Arctic and subarctic regions warm, many cold-adapted species may decline or shift their range. It is not yet clear whether the Greenland shark will be able to adapt to these changes. It may retreat deeper into colder waters, or it may face competition from other predators moving northward. Its long generation time and slow adaptation rate make it especially vulnerable to rapid environmental change. If the waters warm too quickly or prey species decline, Greenland sharks may not be able to adjust in time. Despite all these challenges, the Greenland shark continues its slow path through the depths, undisturbed by the storms and chaos of the surface world. It represents not just a fascinating biological subject, but a philosophical one. In its pace, patience, and persistence, it offers a counterpoint to the frantic rhythms of human life. It does not race or rush. It does not panic or proclaim. It simply exists, quietly and enduringly, across spans of time we can hardly fathom. It asks us to consider the value of longevity, the beauty of slowness, the power of staying still and surviving. What would it mean to live like a Greenland shark, not in biology, but in spirit? To move slowly, consume carefully, act deliberately, and persist no matter what changes come? Perhaps this is the lesson the shark offers, tucked away in the cold and silent ocean where it glides unseen. Not all life must be lived at a breakneck pace. Some lives unfold in silence, in shadows, in deep water. And those lives are no less meaningful or majestic for it not in the years to come. It is likely that our understanding of the Greenland shark will deepen. Technology will improve, and data will accumulate, and interest in the species will continue to grow. New generations of marine scientists, inspired by the mystery of this ancient fish, will take up the task of revealing more about its world. And with every new insight, we will move closer to understanding not just the shark itself, but the vast, cold, and beautiful world it inhabits. For now, the Greenland shark remains one of Earth's great natural enigmas, a creature of patience, darkness, and endurance. It swims through time itself, untouched by centuries, carrying in its body the memory of oceans long past. And though it may never surface in our world with a splash or a roar, its silent passage beneath the ice is enough to inspire awe, curiosity, and a deep respect for the wonders that still lie hidden in the sea. As the search to uncover the Greenland shark's secrets presses on, marine scientists are increasingly aware that they are racing against time, not because the species is disappearing rapidly, but because environmental changes are happening faster than the shark can adapt. The Greenland shark evolved to thrive in a cold, stable, and largely undisturbed environment. The oceans it was born into centuries ago were quieter, colder, and more predictable. Today, as Arctic sea ice melts at unprecedented rates and industrial activity expands into the once remote north, the shark's ancient realm is becoming increasingly unsettled. These changes might not eliminate the species overnight, but even minor disruptions could ripple across centuries of slow and delicate ecological balance. This raises the importance of studying and protecting the Greenland shark, not only as a remarkable species in its own right, but as a biological indicator of long-term ocean health. Because it lives so long and changes so slowly, any major shifts in its population, distribution, or physiology could reveal deep-rooted alterations in the marine environment, changes that might not yet be obvious at the surface. A Greenland shark is not just a species. It's a timeline, an organic archive of centuries of ecological data encoded in flesh, bone, and DNA. To preserve this shark is, in many ways, to preserve a record of the ocean itself. But it's no coincidence that the growing interest in Greenland sharks has emerged alongside a broader fascination with deep time. In an age of rapid technological change and short attention spans, the Greenland shark offers something rare, a tangible connection to the distant past and a sobering glimpse into the future. Its quiet endurance forces us to think beyond human time frames and to consider ecological and evolutionary scales that stretch over millennia. It reminds us that some of Earth's stories are not measured in decades or even centuries, but in ages. This perspective becomes even more profound when we consider the shark's birth date. Imagine a Greenland shark born in the early 1600s. It might have entered the world when Shakespeare was still alive, when Galileo was staring at the stars through his telescope, when the oceans were largely unmapped and filled with sailing ships powered by wind and hope. That same shark could still be alive today, drifting through the deep, entirely unaffected by the centuries of human advancement above its head. Wars have come and gone. Empires have risen and fallen. Cities have been built and buried. And yet, the shark has continued, unbothered and unchanged, in the same cold waters it's always known. What makes the Greenland shark even more remarkable is that it has achieved this not by being dominant or aggressive, but by being quiet, efficient, and extraordinarily well suited to its niche. In a world obsessed with speed, noise, and conquest, the shark thrives by doing the opposite. It is a master of restraint. It burns energy slowly, grows gradually, reproduces infrequently, and simply endures. And in doing so, it has outlived nearly everything around it. There is wisdom in that strategy, a lesson written in its long life and silent movements. There is also humility in recognizing how little we know, even today. Despite centuries of scientific advancement, we still don't know how many Greenland sharks exist, where exactly they give birth, what triggers their mating behaviors, how they communicate if they do at all, or what their social structure looks like. We don't know how many times they reproduce in their life, what diseases they're vulnerable to, or even how old the oldest living individual truly is. Every question answered seemed to uncover three more. This vast frontier of unknowns is both a challenge and a gift, a reminder that mystery still exists in the natural world. While other iconic species like whales, elephants, and big cats are widely celebrated and well documented, the Greenland shark swims under the radar, both literally and figuratively. Its story hasn't been splashed across textbooks or turned into children's stories. It hasn't starred in blockbuster documentaries or become the face of conservation campaigns. And yet, it may be among the most deserving of that spotlight, simply because it represents something so rare and essential, the natural world's capacity for long, quiet, unnoticed survival. From a scientific perspective, the Greenland shark could be one of the most promising organisms for studying senescence, the gradual deterioration of function with age. Unlike most animals, which exhibit clear signs of aging, these sharks appear to maintain bodily integrity over time in a way that defies typical biological decay. Their tissues, organs, and even sensory systems like the nervous and cardiovascular systems may resist aging far more effectively than those of other vertebrates. Understanding how this works could open up new pathways for research in human medicine, including how to slow aging and increase quality of life in later years. There is also increasing interest in how these sharks manage cellular repair and protein stability. Scientists suspect that certain molecules within their bodies may prevent damage to cell membranes, or DNA, over long periods. The combination of cold temperature, low metabolic rate, and perhaps unique biochemical adaptations could hold the key to long-term organismal maintenance. If we can isolate and understand these mechanisms, it could shift the way we think about aging, resilience, and lifespan across all forms of life. Despite their stoic presence, Greenland sharks are not invincible. They are threatened by deep-sea trawling, pollution, and bycatch. Because they are so rarely seen, it is easy to assume that they are safe, that their deep habitat insulates them from human harm. But no place on Earth is truly untouched anymore. Microplastics have been found in even the deepest parts of the ocean. Chemical pollutants sink to the bottom, and fishing operations, whether intentional or not, can severely impact species like the Greenland shark, whose reproduction and population recovery rates are so slow. Even catching a few dozen individuals a year could irreparably harm local populations if those individuals include mature females or rare juveniles. There's also the concern of bioaccumulation over a lifespan of hundreds of years. Any exposure to toxins, heavy metals, or pollutants can build up in dangerous concentrations. Because of this, Greenland sharks may serve as biological indicators for long-term ocean pollution. By studying the contaminants in their tissues, scientists can get a long-view snapshot of marine pollution trends and how those may be affecting ecosystems over time. It's another way these sharks serve not just as individual animals, but as biological archives swimming timelines of ocean health dot in the quiet depths where they drift. Greenland sharks live lives we can hardly imagine. They do not see sunlight. They do not experience seasons as we do. Their world is defined by pressure, darkness, and the slow movements of currents. Time passes differently for them, in a rhythm dictated by cold and instinct. A decade might mean little. A century might pass like a season, and yet they persist, not frozen in time, but flowing slowly through it, like a glacier or a deep current, adapting not by changing fast, but by changing very little at all. If we are wise, we will learn. From this, the Greenland shark teaches that survival is not always about dominance or adaptation in the traditional sense. Sometimes survival is about patience, about waiting, about knowing when to move and when to stay still, about endurance. In a rapidly changing world, that kind of lesson might be more valuable than ever. The shark's way is not our way, but perhaps it offers a glimpse of something we've lost or forgotten. Something slow, ancient, and profoundly enduring. A reminder that in the deep and cold places of the earth, life still holds its secrets close. And if we take the time to listen, to learn, and to protect, we may yet understand what the Greenland shark has always known. The Greenland shark remains a silent guardian of the deep, a living relic of a world long before our own. In its unhurried path through icy waters, it reminds us that not all wisdom comes from speed or change. Some truths are revealed only through time, patience, and quiet endurance. As we look to the future, may we protect what we do not yet fully understand, and honor the ancient lives still unfolding in the dark beneath the waves.